Welcome to Cybersecurity Workshops, and today we're going to talk about network security tools, or maybe this should be called network security devices. And so this is out of the Cyber Basics course in the courseware repository, and Module 2, it's the networking module. We've talked about lots of concepts around networking, and we've talked about different network services, and now we're going to talk about some of the tools that we use in a network to defend it. These are just two of the most prominent network security tools. There are obviously others, but this will introduce this concept of devices and software used to defend networks. So we're going to describe a couple of the basic tools used for network defense, and then one of those network defense devices is a firewall. And we'll talk about firewall rules and what those might look like. And then we're going to talk about intrusion detection / intrusion prevention systems, and we'll see what the difference is between those two. Intrusion detection and intrusion prevention is usually the same device. You can just configure it to do one of those two different modes, and we'll talk about why you might use one over the other. So the basic and probably the earliest network security tool used was a firewall, and the early firewalls were largely designed to sit on a network somewhere and defend a portion of the network, not defend a single host. Although now there are lots of network-based firewall solutions as well as host-based firewall solutions, and we'll even look at how you might configure a host-based firewall, and you can do this yourself if you're using a Windows 10. I'm going to walk through it on a Windows 10 host, and you'll see what that looks like. This is something that, as sort of a casual user, you probably wouldn't do very often, maybe never, but as an IT security person, this is something that you may need to know how to do. And then the other tools that we're going to look at are intrusion detection and intrusion prevention. We're not going to actually do any hands-on with those, but we'll talk about what they are and how they're used in a network. Okay, so starting with network firewalls. Network firewalls are hardware and or software that control network traffic based on source, destination, protocol, context, or content. Okay, so a firewall is all about logically allowing or blocking certain types of network traffic. So it's pretty straightforward, and you might want to allow certain traffic into your network for certain reasons, and you may want to block other traffic because it might be malicious. Is the basic intent. And so the kind of traffic that you want to allow into your network are a couple different types of traffic. First of all, if a device within your network reaches out to a host on the internet, so for example, if you're on your home network and your home computer reaches out to a host on the internet, a web server, you want that traffic return from the web server to be allowed into your network. And that's a basic configuration that almost every firewall allows. They track the state of your session. So when your computer or when a computer on your network calls out to a host on the internet, any firewall on your network is going to allow the response from that device, and the firewall expects that response because it knows that your device called out to that host on the internet. So that's what's called stateful packet inspection or stateful firewall. It tracks the state of the session and allows the responses. Another kind of traffic that you might want to allow in your network is if you host a web server. So some people host web servers in their home. That's maybe it's not very routine, but if you imagine a business, for example, if you're a business and you have a website in your business and that website is hosted in your organization's location within the organization's network, then you want visitors to be allowed to visit that website, right? And so you have to allow their web traffic to come in through your firewall and visit that, reach that web server, and then you want those responses to be able to be returned outbound on your network. And so in that case, you want that external traffic to be allowed into your network, but you only want very specific external traffic to be allowed in. You don't want all traffic to be allowed in. You only want traffic that is going to a certain IP address, the IP address of your web server, and you only want traffic to go to a certain port on that web server. So if it's a HTTPS web server, then you want the traffic to be able to reach port 443, the port for HTTPS, and so you want very specific traffic allowed in, and only that traffic. And so a firewall is intended to control what's allowed into your network and what's not allowed into your network. So a network firewall could be a dedicated device. Or it could be it could be software that's running on another device in your network. We usually think of a network firewall as a dedicated device, and I think probably in most cases, particularly in sort of large networks or in a corporate network, it's usually a separate dedicated device. And there are different firewall types. There's this notion of a packet filter. Packet filters are very simple. They simply filter traffic based on IP address and TCP port or UDP port. So permits or denies traffic based on matching header data to static rules. And that's the simplest kind of a firewall. Most firewalls nowadays are what we call stateful packet filters. And so they do this thing that I just mentioned where they're tracking, for example, when your computer reaches out to a host on the internet, if you have a firewall in your network, almost all firewalls these days are gonna observe, they're gonna be able to recognize that request, and they're gonna be able to automatically allow responses to that request. But they wouldn't allow, if the host, if the website you're going to, if vt.edu website, if that just sort of spontaneously tried to send traffic into my home network, that would not be allowed. But if I request a page from that website, then that response would be allowed. And then there's this notion of an application layer gateway or a proxy, and these are even more sophisticated. So these devices are going beyond just looking at IP addresses and ports and protocols. They're actually looking at application layer data. So they might look at the HTTP data, and they might make decisions based on, certain. I might disallow certain websites, for example. So they might look at the HTTP header and see a website that I have on a blacklist, and they would not allow that particular website, even if the outbound request was a valid one. And then firewalls often provide virtual private network capabilities. So VPN is a way for a host that is outside your network to gain secure access to your network, and that's technology that's often provided in a VPN, and that doesn't have much to do with the natural functioning of the firewall. Allowing or denying specific ports and protocols. So here's some examples of firewall rules, and this is not something that I would expect you to be able to turn around and do, but it just shows some examples of what this might look like, and hopefully this makes sense as I walk through it. So this is pretty standard set of firewall rules. It's very simple. Obviously, this wouldn't work in a lot of this isn't sufficient for most networks. But if you're using just a packet filtering firewall, then you might have a rule that allows outbound traffic. So here we have the action, the direction. So we might allow traffic going out of our network from source address 192.168.star.star. Okay, so this is so my home network, for example, has this IP address space of 192.168.7. Whatever the host is, And so this would allow traffic from any host on my internal network. The destination address is not this, so this is going out of my network, right? Not any host with this IP address. Protocol is TCP, source port, something greater than 1023, destination port 80. So this allows traffic to HTTP sites, and then flags any. So this has to do with IP header flags. So I'm going to allow any flags. And then so this allows this rule allows requests to websites to leave my home network, for example. And then the second rule here is this sort of the reciprocal of this. This allows the responses. So this would assume that this is not a packet. It's not a stateful firewall. It's a packet filtering firewall. This is going to allow traffic into the network from hosts that are not the address of the network to a host 192.168.star.star, so a host within the network. Protocol TCP, source port is 80, so that's a response from a website. Destination port is an ephemeral port, something above 1023, and then this is an acknowledgement. So this allows the acknowledgement, this allows the response from a web server. And this next rule has to do with DNS. So this is HTTP request and response. This is DNS because it's UDP and it's port 53. And so this is how these are, you have allow. So in a general firewall rule set, you have all this stuff that you're going to allow. And then the last rule is very important. This is the deny rule. This denies everything else, right? Deny any. So all the rules above are about allowing the traffic that should be allowed in the network. These are applied top to bottom. So, the firewall is going to, does the packet apply to these rules? No. Check the next one. Does it apply to this? Nope. Does it apply to this? Nope. Does it apply to this? Okay. If it doesn't apply to any of the allow rules, then the last rule should always be a deny all. And that's a very important configuration setting. And sometimes you'll see, when an organization is maybe troubleshooting networks, they might set this to an allow rule, allow all traffic. And then maybe sometimes somebody forgets to turn that back into a deny rule. That's happens sometimes. It's definitely not a good thing, but it's important to remember that the last firewall rule should always be a deny. Deny everything that's not allowed. So top to bottom, first match wins. Some examples, Cisco has these access control lists, look something like this, and then there's the Linux, Unix IP tables. That's host-based firewall for Unix or Linux. So host-based firewalls come with, most hosts these days come with a built-in firewall. So your Windows 10 computer has a built-in firewall. You can turn that off. It's kind of this default. The default behavior is that it's on. Mac OS comes with a built-in firewall. Linux comes with built-in firewall called IP tables, and then there are also some third-party vendors that provide host-based firewalls. So there's Semantic Endpoint Protection, McAfee Endpoint Protection. Various third parties. I think nowadays the third-party firewall, host-based firewall market isn't very vibrant because again, hosts have most host operating systems come with this functionality, by default. And these endpoint firewalls can be configured for specific IPs and protocols, just like network firewalls can, right? So you can configure your host-based firewall to allow certain traffic in or out. And so, we'll just take a look at this real quick. I'm going to hit my Windows key. I'm on a Windows 10 computer. I'm going to hit my Windows key, and I'm going to type in firewall. And I get this firewall window that comes up, and has some information about my configuration, right? So I happen to be on a home network on this computer. So it shows one private network. I'm connected to a private network, and it's this Raymond 1 network, Raymond 1 space 2. I'm not sure why the space 2 is there, but this is a home network, and it's a private network, right? So it's a trusted network. This is my home network, and then there's this other category. It says guest or public networks. I'm not connected to any of those, but if I was at an airport or at a coffee shop or somewhere in a public space, I might be connected to a public network. And you can set different rules for private networks versus public networks on your Windows system, and and again, most of this is set by default, and you know, and you don't have to do a lot of this configuration yourself. Okay, so so these are the basic settings just looked at, right? So we'll look at an example here. Here's just a quick example. Let's say you want to run a Minecraft server on your home Windows 10 computer, and you want to be able to allow hosts on your home network to be able to connect to that. Then what you might have to do is set up your Windows host-based firewall to allow TCP port 25565. That's the standard port for Minecraft servers. And so I might have to configure my local firewall to allow those connections. And so so to do that, we'll just take a look at it here. So you would open the Windows Firewall like I just did. You go to Advanced Settings. You want to go to Inbound Rules. My circle's in the wrong place, or my circle is a little bit off here. We want to go to Inbound Rules, not Outbound Rules. And then you go to New Rule, and then you're going to specify the rule type. So this is a port-based rule, and we're allowing a TCP connection on port 25565. Again, that's the Minecraft port. And then the action is to allow that connection. We're allowing it on the private network, right? We don't want to allow this to happen if we're in a coffee shop. We only want to allow it when we're on what we consider a secure network. And then we can name the rule and put in some comments, and then we see that rule show up in our list, right? So if I go back to my firewall configuration, if I go to Advanced Settings, so I look at the inbound rules, and again, I'm allowing people to connect to my computer. So I'm going to say New Rule. And it's on a port. I know the port that I'm going to use, so I go to Next. TCP port, and I said it was 25565. That's the Minecraft server port. Next. I'm going to allow the connection. Next. And I only want to allow this on private network, so I'm going to allow this on my home network. And then might call this Minecraft, and then accept Minecraft connections, and this is assuming I'm running a Minecraft server on my device. Okay, and I click Finish. Okay, so now what I see here is the very first rule is this Minecraft allows people to connect to the Minecraft server on my device. And now down here, when I select that, if I select another rule, I see I get a different thing down here. If I select that Minecraft rule, now I can turn this rule on and off, right? So I can disable the rule. So now the rule is off. If it doesn't have a green check mark, then the rule is not active. Or I can enable the rule, and now the rule is active, and I may even want to turn that thing on and off when the server is active or not. Okay, so that's how you set this stuff up on a private on a Windows 10 system. Again, it's something that you're not going to do very often, but that's a situation where you might have to do that thing. Okay, so let's go back to slides here. Okay, so I'll move on to intrusion detection. So intrusion detection systems, this is different from a firewall. A firewall is applying some rules to either allow traffic or not. It's pretty static. An intrusion detection system is a different thing. An IDS is going to try to detect and document malicious or anomalous activity. So this is going to actually try to identify when people are maliciously trying to connect, right? The firewall just allows traffic or not. It's not trying to make judgments about the traffic. And IDS is different. And IDS is trying to make a judgment based on the traffic. It's gonna when it sees something that it thinks might be an intrusion attempt, then it's gonna send an alert. So there are host-based IDSs or HIDs that are may look at things like file integrity, user behavior, may look at process behavior, may look at the local logs and audit. And there are also these network intrusion detection systems, or NIDS, and they're going to do this packet inspection. Might look at traffic flow patterns in and out of the network. They might look at they might look at overhead on individual hosts, or the amount of traffic going to and from individual hosts. Might look for anomalies, and a network intrusion detection is going to be looking at the most likely threats. Okay, and then intrusion protection is a little bit different. So intrusion detection, what those systems do is they identify potential intrusions, and then they alert somebody. So they alert a network analyst. So those systems assume that somebody is going to be there to accept an alert and then take action, if do some investigation and take some action. And then you can go a step further and you can set things up as an IPS, intrusion protection system. And these identify potential malicious activity and then take action to block that activity. And so here I asked sort of the rhetorical question, what could go wrong? Well, here's what could go wrong. The trouble with intrusion detection and intrusion protection is they have a high false positive rate. And a false positive means they often flag things as malicious when they're really not malicious. And so if you have, and that's why we don't just set everything up as an IPS. It's because of this problem of false positives. And so if, with a firewall, it's very clear, we're very clear about what traffic is allowed and what traffic is not allowed, and there's really no room for a false positive unless you misconfigure something. But with an IDS, this system is trying to make it sort of a judgment call, because some traffic may appear malicious but not be. And no matter how carefully you tune these things, it's almost impossible to get rid of this notion of a false positive. So an IPS is actually going to stop traffic, and so it has to have a very low false positive rate. But if as you reduce the false positive rate, then generally you end up increasing the false negative rate, meaning you allow traffic that shouldn't be allowed. So that's what could go wrong. Approaches for IDS. A couple of basic approaches. There's signature-based tools, so simple signatures. Alert if you see this specific thing happening. With this, you have few false positives, but it's ineffective against unknown threats, right? So the firewall rule set, or the IDS rule set, has to be up to date. And if it's a new threat, then the rule, there's not going to be a rule for it, right? So then the other option is an anomaly detection approach. So this is alert me if something unusual happens. So what's unusual? And these systems set this baseline of routine traffic, and they'll use some statistical models or some machine learning or AI to try to baseline the traffic, and then identify things that are not part of the baseline. And these are interesting. There's lots of cool research into these. These can detect unknown threats, but they tend to have lots of false positives, because sometimes you get anomalous behavior that's just anomalous. It's not malicious. It's not an intrusion. It's just new behavior on the network that hasn't been seen before. So maybe you install some new network device that is receiving traffic that the IPS has not seen before, and the IPS or IDS is going to say, hey, that's anomalous. That's not routine traffic. That's not in my baseline, so I'm going to block that. Well, if that's an authorized device on the network, then that obviously is a false positive. Some tools out there. Snort is a very popular free open source IDS, which can also be configured as an IPS. I'll give a simple rule example here. I'm not going to really talk much about that. Suricata is another open source IDS. Zeek is a very popular open source IDS. Used to be called Bro. They changed the name about, I don't know, in 2018 maybe they changed the name to Zeek. But it's very popular. Some paid products. These are just examples. There's a ton of paid devices out there. Cisco has IDSs, StoneSoft, Mandiant, just a bunch of commercial IDS and IPS tools. And the benefit you get from a commercial tool is you get customer support. You pay for it, but you get customer support and updated rule sets, and there's definitely benefits. There's just a cost to getting those benefits. Okay. Okay, so that's firewalls and intrusion detection. And next time, I think we're going to get hands-on with some Wireshark and inspecting network packets. So thanks for joining, and we'll see you next time.